my subset to be, you guys are a subset of gross 1 students, yes? You with me? No, this is not gonna work perfect. But if I had an operation and the answer was Joe, who's over in the next building, did we have to leave this room? Yes. So if I have a set, it's a room, it's in a room. I got a room, there's a bouncer at the door. What does it take to get in the door? You gotta do this thing, right? And then if you're in the room and you interact with other vectors, you shouldn't have to leave the room. That's why it's called closure. The door stays closed. But if I add these three that are in the room, I've got to go outside the damn room to go get this guy. So is it closed? No. It's a beautiful thing. Now, closure has a different meaning in like psychology. You can use closure after a breakup or something. That's not what this is, thankfully, because The Love Life of Vectors sounds like a great little book, but I don't know what that would be. Hey. Okay, let me catch up with quizzes here. Sarah is not here. Jean, I think she was going to be out. Carlos. Hey. Chris Espinoza. Chris. Ivan Espinoza. Man, I'm Espinoza-less. Anthony. G. Oh. Alan. Renaud. Alan. Basil. Hey, oh sorry. We're good. V. Ricardo. Montez. Kent. Wynn. Kent. Joseph will come in later as he does all the time. Livette is not here. Mimi is not here. Isabella is not here. Oh. Sir Khan? Get him over. Sir Khan. Paul. By the way, with the last name of W, I understand what it's like to wait. I was always last at lunch, and we got the weird hot dogs when I was in second grade. The mistake was 171. They lined us up alphabetically, so the W's were screwed. Anyway, so look that over for like a minute or two. Let me know if you have any questions. Let me put the stats up here. Oh yeah. Hey. Close. All right, guys. Just to say this again, on your 2A, number 2A, I'll say this again. If I took 2 points off and you did the transpose and showed it was the same, I'll give you those points back. If you make corrections, put a little note. You with me? My intent with that question, because part B is find the transpose. So it kind of inherently means part A, you shouldn't do the transpose yet. So if I just stare at a matrix, how can I tell it's symmetric? That's really what I was asking you for part A. But after a while, I thought, that's a little picky. So I was going to go back and give those back, and I don't think I made it back to everybody. So you guys kind of with me? So 2A, if I took 2 points off because you did the transpose method, just put a little note in your corrections. Or if you don't feel like doing corrections, you can just tell me and I'll make a little note. Yes? Give you 2 points back. You with me? Okay, hopefully, okay. Anything from homework? Any questions? Yeah.
3.3 question 9 part either A or B honestly, but either or.
Three. Oh boy, it's clear as day. Come on, little dude. There we go. Okay. Shoot. You said number 9, yes?
Yes.
Okay. Okay. So, find the complete solution. So what does XP mean? Yeah.
It's like the extra you add.
Yeah, it's a little, yeah, exactly. When you do the whole process, it's the extra that doesn't have a variable attached to your S or whatever. And then, of course, XN, officially they're from the null space, and they're the ones that have the letters attached. Yes? So the idea is, if you can put this into matrix form, you can just attack it like we have. Now, this one's a little weird. What would the matrix be for this one?
1, 1, 1, 4.
Yeah, and it's only got one row, yeah? Right? So, if you're trying to find, for example, can you find the null space for this? Actually, let's just cut to the chase. We're there. The funny thing, if there's one equation, you're there. Because what do we normally do is we'll set each row equal, and then we'll figure out who's the free variable, whatever. You with me? Right? Yes, yes? Okay. So in this problem, I've got my one equation. My first variable is what I normally consider to be the one that depends on these two. These are going to be the free ones. So this would be, what can you call y? T. And what can you call z? W. I love it. Screw your S, Jeff. So then x is, so x1, or you can leave it as x. X is t is 4 minus t minus w. Y is t, and z is w. You guys got it with me? Okay. So obviously, how big is the null space? What's the rank of the null space? What's the dimensions? How many variables did you take? Or if you want to, break this up into the t-dependent vector and the w-dependent vector, and like you said earlier, the extra, which would be the particular solution, right? You guys with me?
Two-dimensional.
You would say again?
Two-dimensional.
Yes, good, two-dimensional, because it took two variables, right? There are two free variables, so it must be two-dimensional. I like it. Okay. How many columns are there? 3. And how many rows are there? 1. So it makes sense that my column space rank is 1. So where do the other 2 go? Null space. So that's not surprising. Did you have to know ahead of time? No. Could you know ahead of time? Yeah. Right, so you know how many variable dependencies to expect. Are we out? Is that okay? That one I understand is trippy because we have not really looked at a single line before. Another way to look at this is how many variables do you have to tell me before I finally know all 3? How many variables do you have to give me values for until I can know all 3 for sure? You could do it. How many variables? 2 of them. Once you tell me the value of 2 of them, I can figure out the 3rd. And that's what this idea of a free variable is. Those 2 are free to be whatever the shit they want to be. Couldn't you make y 87? And couldn't you make z 18 billion and 3? And then you can figure out what x is, correct? To make the result come out to be 4. X is going to be some big-ass negative number, yes? You guys kind of see what I'm saying? So, has anyone ever taken statistics before, out of curiosity? I'm about to say a phrase, don't worry about it unless you just raise your hand. Degrees of freedom. This is kind of related to degrees of freedom. How much freedom do you have to choose until you have to get real and make it work? I don't know if your instructor explained why it was called degrees of freedom, the N-1. No? Damn. I'm not gonna, sorry. Is that okay? And part B should be a little more traditional.
Yeah,
It might have some weirdness to it, but I mean, can you attack part B pretty?
I think so.
Okay. So part of it was you weren't sure what they were asking for? So I mean,
It
in
was
this
because
case.
it was one line.
Huh?
Like it
Oh
was-
yeah, I understand. Part A, I understand that it freaked you out because you're like, wait a minute. But that's why the null space is so big, is because this is very, very, very underdetermined. Yes? Okay. Anything else from homework or from the quiz? Anything? Anybody else not get their quiz back? Okay. All right. I'm not sure how to take that because I know the homework gets weird. So many guys have no questions. I'm like, well, nobody's doing it. Shit. So let me give you this. I have done something very nice for you. I have kind of collected a bunch of notes from recent stuff. Get used to this. Just to kind of help. Yeah, let's start on that side. That's probably better. These are all curly. I want to do an example with you based off of this. That's going to get us into chapter 4. Oh, yeah. Let's see. So I didn't really put a. I didn't really put a section. It's basically from chapter 3. Yes?
Is it like 3534?
You guys good? What's up? Oh, what happened? Oh, man.
Is it 3 pages or is it one?
It should be back and front. How many guys got gypped off?
I think mine is.
My picture loves to mess with me.
I thought you gave me like 3 pages of the same like package.
Gotcha. Did everybody get a two-sided sheet? Two-sided? Yes? Make sure it's got 2 sides? 2 sides? Okay. All right. That made me worry really bad because I was like, oh crap, how many did that happen to? So guys, does this sound familiar here? Does any of this sound familiar? Okay. So this is what you should be doing. So I have no idea how anybody studies, but the way I studied, and I was a super little geeky boy, yes, still am, I would rewrite all my notes and collect everything together that was sort of related. Right, so I would have notes first, and then I would rewrite the notes organized from blah, 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 blah. And I got to the point in some classes where if you said this idea, I would tell you what section it was in the book. Yes, that's kind of silly. I'm not expecting you to do that. So I kind of done that for you. These are all things, everything on here we've discussed. There might be 1 or 2 that was in the book that I didn't really discuss directly. You all should be reading the book. Okay. So what I want to do is I want to do an example that kind of explores all of these things. On the other side is the four fundamental subspaces. Now, I don't think we got down to here yet. And that sounds weird as shit. You with me? So what I think I want to do, let me do this first. Before we do the example, I'm going to get us up to where this sheet is. Then we'll do an example. We'll see how it kind of fits into all of these descriptions. And then we'll see how it actually leads us into chapter 4. There is one thing in section 3.5 that I'm going to come back to after spring break. But it needs a little more room than I'm going to be able to give it in here. I don't know if anybody's looked ahead to 3.5. There's something called an incidence matrix. No? This is kind of a huge idea. This is what, like computer networks, you often think of them in terms of nodes and pathways and so forth. So it's kind of a way to set up a matrix to represent all of the nodes and all of the pathways of information that go into and out of those nodes. You can actually make a matrix that represents that. And then the analysis of the matrix has to do with physical properties of whatever that is. So it could be used to analyze circuits, electrical current through a circuit. Have you guys ever heard of Kirchhoff's laws? Anybody? We're not going to suddenly study a lot of physics, don't freak out. But I might bring that up again when we get back into it, okay? But I want an entire class just for that, just about. Or half of it maybe or something, we'll see. So let me catch us up to where we need to be. Did I bring paper? Maybe. I'll use this, yes, perfect. Oh yeah, I forgot, let me do this. So we get less glare. I'm pretty sure this probably makes it easier to tell if you're watching the YouTube videos at all. So you don't get any of that glare going on. Okay. I think, let me try to remember, the last thing we talked about. Let's see if I remember. Blah, 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 blah. Yeah, exactly. Let me see if I remember where I left off.
It was if m was less than n.
Oh, there it is. Okay. So did I say this? Just let me see if I said this. What happens when the only solution zoom out a bit. When the only solution to ax equals 0 is x equals 0. Can anyone tell me anything that must be true then?
Is this 3?
This is 3/4. Yeah. Sorry, say it again? Okay, good. It's full rank, invertible, kick ass. I love it. So then this would be A's got full rank. It's invertible. If it's invertible, what kind of matrix must it be? Square. So we know it's square. Okay. And behind everything you've told me, what's the most basic thing you can tell me about the matrix A, and more specifically, the vectors that go into making its columns? I don't think anyone said this yet, but they're all linearly independent. Okay. All column vectors are linearly independent. Lindependent. So what is the only thing that's in this? Yeah, only contains the 0 vector. I love it. You guys all with me? So if I write it like that, I haven't told you what dimension I'm in, because who cares? I can be whatever the hell dimension, as long as it's a square matrix. I like it. So if you really stop, all right, I have no idea how you feel about everything we've talked about so far. We've actually done a lot. And we're finally getting to more, I think, concrete kind of stuff you can sink your teeth into. I don't know if you guys agree. Even the LU factorization was kind of a little amorphous and so forth, but we're solving equations, which feels more like bread and butter math stuff. Okay. Let me zoom ahead to where I think I ended up. Yeah, okay, that's the last thing. Okay, got you. So let me ask you this. So if I have an invertible n by n matrix, Interval? Sure, Jeff. Oh boy. A is an n by n, we say this, is an n by n invertible matrix. What's true about the column vectors? Beyond them being independent, what do they form?
Row space.
A basis for. Now you could say the column vectors form a basis for the column space, but that's kind of silly. Plus, you might not be right if it's just a general matrix, yes, because some of them might be dependent. Yeah. So how big is our matrix? N by n. What specific space? Rn. I love it. Cool. So the column vectors form a basis for Rn. And of course we know that because something I might not have articulated directly. To be a basis set, what has to happen? To be a basis, to have vectors that form a basis for a space. They have to be independent, and their linear combinations must span the space. You guys with me? Span is a great word. It captures the idea of stay within, but also completely cover. You guys with me? Okay. Like it. Okay. These are little things that are, I might not have directly said, but we've kind of danced around a bit. Blah 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 blah. Okay. One little thing that I talked to somebody about, and I'm not going to spend a ton of time on this. I think it came up once before. Can you guys? This is going to seem kind of silly, but this is a quick little side note. Can somebody just tell me the most general quadratic function? Yes. Ax squared plus bx equals plus c. Do you see how that connects to basis vectors in any way? Isn't that a linear combination of things? What things? X squared. So this is my basis for quadratic functions. By the way, this is a quick way to write function, and this is a quick way to write equation. You guys with me? And with my writing, you want very quick ways for me to write things. So a basis for quadratic functions would be x squared, x, and 1. Is that cool? That is a basis for the space of all quadratic functions. You guys with me? That's just a side note, because obviously what are we going to mostly focus on? Spaces that are created from vectors. Yes, row space, column space, blah, blah, blah. Okay. But just to let you know, the idea, and this has come up once before, if I remember correctly, just all the ideas we're talking about actually go beyond just vectors. They can go here. We talked about 2 by 2 matrix space. You guys remember? There's a 0 vector. Every linear combination is still a 2 by 2 matrix, so it's closed. Yes. If you do any linear combination of those things, do you get something that's not I shouldn't say quadratic because a could be 0, but polynomial up to degree 2. Okay. All right. So that's enough of that side note. Get out of here. 3.5, I try to pick out some of the stuff that's new in 3.5. So I don't know if anyone's tried to look at 3.5 yet. I told you a while back 3.4 and 3.5 is mostly review. I picked out a few things that might be not quite just review. What does this notation mean again? Column space, yeah. And what does this notation mean? A transpose, yes. So if A is n by n, I'm sorry, m by n, what is A transpose? N by m, I love it. So what does this represent? I'll accept 2 answers.
Column space of A transpose.
Yeah, column space of A transpose.
Or the row space.
I love it. Good Lord, Jeff. quick side note for you guys. Mondays and Wednesdays were like crazy long for me. Today we had a defense of our program, of the math program, that I was one of the 2 people that put it together. So I'm like extra specially like, so I'm sorry, I'm really running really bad even for me. So that's beautiful. Okay, so it kind of makes sense. If I transpose, so we've talked about this before. When I can get my column space, I'm not sure why somebody would want to do this, but I can get basis vectors for my column space that are actually present in my original vectors, yes? In my original matrix. You guys with me? So if I transpose it, I can do the same thing for my rows. Now what is the more direct way to get a basis set for my rows? Just row reduce A, and then I can see what's left in my R0, right? My R, when I take those zeros out. Okay. So I didn't remember if I had really written this much yet or not, but this is just another name for the row space of A. Okay. Oh, okay, here we go. So now that I've introduced the idea that we can analyze A transpose, we can then talk about this. So I mean, that directly, what does that represent?
For null space.
The null space of A transpose. So what's another way to say that? That's the null space of our row space, yes? The null space that's adjacent to our row space. So we're going to kind of solidify what I just said, because what I just said was not very technical, yes? This is what is called the left null space for 2 reasons. One, if I just say null space, I want everybody to understand what I mean. I mean the space we've looked at before, and this is not that, yes? We have not looked at this, have we? I don't think we've done a problem directly where I said the null space of the transpose of A. You guys with me? Okay. So on one level, I want to give it a different name, just to kind of make it stand out. So when I say null space, you know what I mean? And if I say left null space, you know what I mean. Now, a really good question is, what the shit is up with left? Why couldn't you call it null space 2 or null space the return or something? Yes? So here's why. If an element is, if a vector x is in the null space, in the left null space, what must be true? Because null space comes from somewhere very specific.
It's in the null space. It's in the right of it.
And what you should tell me right now, just to let you know what I'm looking for, is very little words. I want an equation. If x is in the left null space, what equation must it satisfy? Exactly. Because if x is in the null space, it must do ax equals 0. So if x is in the left null space, it must do A transpose. Okay, now what if I transpose both sides of this thing? Does anyone remember how this works? What goes first now? X transpose. And like Zach just said, the transposes here just cancel out. So what side of my matrix is my vectors attacking from? Or R, if I want to use grammar correctly. From the left, okay, so that's why we call it the left null space, because I could write it like this. So they were like, should we call it like null space extra? No, so they said, oh, what about this? We'll just call it left null space because of this. And they're like, all right, sounds great. You guys kind of, that was the drunk history of this. Not literally, thankfully. There's water in there. But that was like a rough idea of how they came about this. Okay. And a quick little example. If I give you A, 1, 1, 1, 2, 1, 3, which is a very exciting little matrix. Can you guys, well, let's do this together because I'm going to make you do a lot of stuff here in a minute. What's A transpose?
1, 2.
Should be cool, yeah. Transpose is awesome, yes. And then how do we start to analyze this guy's null space? Yeah, row reduce. So I could do this minus this, yes? 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2. One more thing I can do, yes? What's not quite right?
There is a.
Yeah, where are my leading ones? In the first and second column, there should be a leading one in the second column, but there's supposed to be a 0 above it, so I can make that happen. Because of this guy, yes? Zeros kick ass because they're not going to screw with whatever's above or below them. So then this guy can directly attack this guy. So if I just take this, let me do it this way. This, this minus this. So I do 1, 0, negative 1. There. So that's something we should all be very cool with. If you guys have noticed, I mostly have given you matrices that do not take very long to reduce. And that's why I want to see you do it by hand, because it doesn't take very long. There will be a time when I will give you a matrix that's really big and gross, and I will let you put it in your calculator, and I will state that. So when do you know you can use a calculator to actually do the problem? When I say you can. If I don't say it, do it. Okay. So this was not long. Can somebody tell me the null space straight from this? Well, let's do this. How do I do the null space traditionally?
AX equals 0.
Well, yeah, ATX equals 0. Yeah, so that's kind of like in the background. So I'm going to set this equal to 0.
So x1 minus x3.
Yeah, x1 minus x3 is 0.
And then x2 plus 2x3 equals 0.
Good.
And finally,
Now, just to point this out, if I had a vector negative 1, 1, 0, wouldn't that make this come out to be 0, 0, 0? Yes? All right. So, let's see. What do I get here? What's my free variable?
x3.
x3 is my free variable. So x1 will be t or s or w or whatever you want to use. x2 will be negative 2
Wait.
t. What's up? Sorry.
Oh, no, right.
And x3, of course, is what I call t. So then I get 1, negative 2, 1, t. So one little thing I forgot was this poor guy's got to come into play. So 1, negative 2, 1. So if this is 1, that'll cancel with that one. If this is negative 2, that'll cancel with that 2. So you could bypass this if you were two things. You understood what was supposed to happen and you were more awake. Then you could bypass that whole process. I'm not sure if anybody's with me. I think some of you guys already saw this. You could actually just kind of tease out from R the actual null space. If you do that, just say very quickly, I saw this and this, right? Because I'm always a big proponent of the more you know, the less you should have to do. But don't just make magic happen, right? You got to tell me what you actually saw. Okay. Okay, so what would this officially be? This here? What is it about that vector that's special?
Basis for the null space.
Basis for the what kind of null space?
Left.
Yes, this is a basis for the left null space. Because my original vector was this, and we worked with the transpose. So I find the null space the same as always. It's just that I wasn't working with A, I was working with AT, so we call it the left null space. Because if I said, what is the null space of A, have we done no work for that? Nope. Okay, I like it. You would, Jeff. Okay. Does that make more sense now, left null space? I hope it makes sense just on a verse level of it's another null space. We have to give it a special name, or else I can't distinguish. And then left makes sense because of a certain mathematical property. Okay. Yeah, good. I'm there. Okay. All right, this is going to be really, really silly. Do you guys remember the fundamental theorem of calculus? What I was affectionately called F-top. Anybody remember? Does anybody remember that phrase? Fundamental theorem of calculus. Somebody's very interestingly looking at me like, I sure don't. Like proud or something. I'm not sure I can say that. Fundamental theorem of calculus is what set up the idea of the derivative of an integral. That was the first part. And the second part was what I affectionately called big ass F notation. The integral of little f. from A to B is big S f of B minus big S f of A. Yes, that's how integrals work. You with me? So it makes sense. That's called the fundamental theorem of calculus, because that's how freaking calculus works. After that, yes. Here's something kind of silly. This one is called the fundamental theorem of linear algebra, part 1. FTOLA. That's what I'm going to call it. And these are two things that are very kind of silly. Column and row spaces. What is automatically true about them? How do they relate to each other? Have the same... Yeah, and what do we call it? Rank. Okay. And secondly, the null spaces. You ready? Now, is everybody cool when I say null spaces? You all have to, because we have the null space and we have the left space. So the null spaces have dimensions m minus r and n minus r respectively. Okay. Yeah, that's the one. Yeah, all right. These two are things we've already talked about before, yes? So I always, again, you all know I'm aware of the shortcomings of the book. But it is kind of funny how he seems to catch up with himself a lot. So he makes this big thing and then you're like, yeah, we talked about both of those things before. Okay. So there's nothing ground shaking. There's a part 2 obviously coming up here later, and that's a little more interesting. So here's what I want you guys to do. Everybody got one of these, is that true? Did everybody get one of these? And everybody got one that has 2 sides to it, yes? Some people's have the extra added bonus? I wouldn't call it bonus. Okay. Here's what I want you to do. You're going to be very excited by this. I'm going to give you a matrix. And look at this beautiful matrix here. Let me make sure I get all my negatives or else it's going to screw you over. Oh boy, okay. Make sure I can read my own writing. This should be exciting. Okay. Oh, is this a... Let me double check something, everybody. Oh, that'll work, yeah. Let me look at one thing, guys, hold on. Bum, 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 bum. Yeah, okay, that'll work, and that will work, okay. Yeah, perfect, okay, that's right, okay. Now, full disclosure, I try to create this to do something else, but then I worked with this and I realized it did something perfect, so I'm very happy with this. And you're like, good for you. So how big is this sucker?
4 by
4 by
4.
5. Is it possible to be full rank?
No.
Good. Automatically, which space could have a problem in terms of not being, like, could it have full column rank or could it have full row rank?
Full row.
It could have full row rank. Does everybody see that? Why can't it have full column rank?
Because the columns are...
I have an extra column, right? So on one level, before you do anything, before you even look at the numbers, because I know once you look at the numbers, you can see that there's an obvious. But if you just saw there are 5 column vectors with 4 things that, why can't all of them be linearly independent?
Because 5 doesn't equal 4.
Yeah, 5 doesn't equal 4. I love that.
Just 4 equations and...
Yeah, exactly. 4 equations with 5 unknowns. Right? So one of them has to be, at least one of them has to be linearly dependent on the other ones. Okay. So what I want you to do, now understandably, this one's a little bit more, but can you see how a lot of good shit's gonna happen? So I want you to find all 4 subspaces, their basis vectors. All four. So just to remind you, you've got a list of them. You've got the two big ones that we've been talking about forever, column space, row space. Then you have our normal null space. And then you have the weird little left null space. Yes? So that's what I want you to do. So you can. Maybe what now?
Is it gonna be like a little bit of 4, like all 3, like the 2.4, all 3, and then a little of 4?
Yes.
Okay.
Sorry. I didn't restart my recording, so it kind of sucks. But for the people at home, this is the work. I'm very sorry, and this is something I wrote. Have a good time.